is a type of transformation that does not, so we're going to fill in does not preserve distance, but it does preserve angles. So if your triangle has angles inside of it, all the angles are staying exactly the same measure. The distance, the sides are what's changing. So the distance does not stay the same. So what this means is my object could get smaller or bigger, and then I could also shift it left, right, or I could reflect it across the x-axis. So if you flip to the back right now, I put all of the old, basically all that information from the poster. Translations, remember, we take an X and we add a number, or we subtract a number if we want to go left or right. The Y is the up or down. So we should maybe add that. So remember, the X is left, right. The right is where we add, the left is where we subtract. Y is if we go up, we add. If we go down, we subtract. And the reason why I left them blank, you don't have to fill in anything, it's because it's the number that it says. So if it says to the left 3, you would take X and you would minus 3. I also put all the lines of reflections and I put all the rotations. So all of this stuff is old. There's a couple questions that involve some of the old stuff. So it's going to say to dilate it and then also shift it to the right or shift it down or rotate it. So this is all old stuff. So if it's left, you subtract a number. If it's right, you add a number. If you're going up, you add a number. If you're going down, you are subtracting a number. So back to the front, a dilation is changing the size. So there's something called a scale factor. A scale factor you would have learned about in middle school. A scale factor is technically known by K. A scale factor is used to change the size of a polygon, so any shape. If K is greater than 1, so this takes you back to like elementary school and the alligator is going to eat the bigger number. So if K is larger than 1, like 2, 3, 4.5, then the size is going to increase. If K is between 0 and 1, so what's an example between 0 and 1? Because this is a compound inequality you would have learned about in Algebra 1. What would be a number between 0 and 1? 0.5, 0.7, whatever, 0.75, any of these numbers, that is going to be decreasing in size. So it's going to get smaller. So it says if quadrilateral LMNK has vertices L, blah, 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 and is dilated by a scale factor of 1/2, this is going to be my K. K is going to be 1/2. Determine the coordinates of L prime, M prime, N prime, and K prime. So let's start by determining, should my shape get smaller or bigger if my scale factor is 1/2? Smaller, because 1/2 is technically 0.5. So this is going to get smaller. So what I'm going to do to start is I'm going to plot my original coordinate points on my graph. And when we're doing this together, we're going to use the graph. You don't need to use the graph whenever you're doing it yourself if you don't want to. So take a second, plot your original points. So 4, 7, 1, 2, 3, 4, 5, 6, 7. 6, 5, 1, 2, 3, 4, 5. 4, 1, 2, 5. So we have a kite. That's the original. Now we need to figure out where it's going to be if it's shrinking in size because my scale factor is 0.5. So to actually figure out the coordinate points, what I'm going to do is I'm going to take my original coordinate points and I'm going to multiply by my scale factor. So I'm going to multiply by 1/2, which is technically 0.5, which is really just dividing by 2. Okay, I started with a very nice scale factor. They're not always going to be this easy just because 1/2 is easy to like visualize. So if L was 4, 7, I'm technically multiplying each coordinate point by 0.5, which is 1/2. So if L was 4, 7, does anybody think that they know what L prime is going to be now? if I multiply by 0.5 or if I multiply by 1/2. If I take 4 and I multiply by 1/2, what do I get? 2, because it's cutting it in half. So it was 4, now it's 2. 7 cut in half is going to be what? 3.5. And I'm going to do the same thing to M. M was 6 comma 5. Now what is it going to be if I multiply by 1/2? 3 comma what? 2.5. And same thing, I'm just multiplying by 1/2 or 0.5. If you want to use, you can use a calculator for this. I'm taking 4, I'm multiplying by 1/2. 4 cut in half is 2. I have 1 cut in half is 0.5. And then K, same thing, I'm cutting it in half. It was 2 cut in half is 1. 5 cut in half is 2.5. So when I plot these points, it should look like the image got smaller because my K value, my scale factor is 1/2. So it's 1/2 the size of the original shape. So I'm going to plot my new points. So I'm going over 2 and up 3.5. 1, 2, 3.5. Over 3, up 2.5. Over 2, up 1/2. And over 1, up 2.5. So now I have like a cute little baby kite. I put that point. It's a little weird. Yes. Yeah, baby kite. So your image should get smaller if your scale factor is less than 1, basically. If it's more than 1, then it should be getting bigger. How do we feel? Not too bad? Let's go to, there's specific numbers I want to go to. Let's go to number 4. So whenever you're doing these, if you want to use the graph, you can use the graph. If you just want to write out the coordinate points, you can write out the coordinate points. Either way is fine with me. The coordinate points are really what's going to be on the EOC anyways. So if you don't want to make the graph, you don't have to make the graph, but some people like to use the graph. So let's go to number 4. Number 4 says, and this is where your calculator is going to need to be used. Number 4 says, determine the new location of triangle ABC if A is 1, 3, B is 7, 2, C is 9, -2, and the triangle is dilated with a scale factor of 7/3 centered around the origin. So it should always say centered around the origin. So don't let the wording confuse you because there's going to be words on your EOC. So just look at what you got to do. It's being dilated. It has a scale factor of 7/3. So last time it was 1/2. And in a calculator, if you take 1 and you divide by 2, you get 0.5. 1/2 is 0.5. We're going to do the same thing with 7/3. There's a couple different ways you could do this, but most people just want to use the calculator. So if I have A was 1, 3. I have to use my scale factor 7/3. I'm going to change 7/3 into a decimal. So 7/3 is a fraction. A fraction is fancy division. So if I take 7 in a calculator and I divide by 3, I get 2.3 repeating. So my scale factor, my K, is 2.3 repeating. Does that mean that my numbers should get bigger or should they get smaller? They should get bigger. It should get larger because technically, even though it's a fraction, it's larger than 1. So this should get bigger. So you got to keep that in mind. So in my calculator, I'm going to use this repeating decimal and I'm going to multiply my A by both of those numbers. So if I take 1 and I multiply by 2.3 repeating, what am I going to get? 2.3 repeating, right? Because it's 1. So for A prime, the first value is going to be 2.3 repeating. And I'm going to do the same thing for each number. So I have to use 2.3 repeating, though I cannot round it to 2.3. because on the EOC, they're going to want some of the numbers you'll see are going to come out exactly the way they're supposed, like as whole numbers. So if I take 7 and I divide by 3, I have that crazy decimal back in my calculator, and I'm multiplying by y, which is 3. So I'm going to multiply by 3. And this is why you have to use the repeating decimal in the calculator, because this comes out to be 7. If I just use 2.3 rounded and I multiply by 3, it comes out as 6.9. And on the EOC, it's not going to be always going to be multiple choice to where you could be like, oh, it's probably supposed to be 7. They're going to have like little blanks that you have to fill in. Okay, so just be careful. You're going to want to use the whole decimal if they give you something a little crazy. So B's coordinate point was 7, 2. I need to find B prime by doing the same thing. So B was 7, 2. I'm going to take my scale factor, which is 7 divided by 3. I have that whole decimal in my calculator. I'm multiplying by x, which is 7. So I get 16.3 repeating. And I'm going to do the same thing with y. 7 divided by 3. Have that whole thing in my calculator. I'm multiplying by 2. So I get 4.6 repeating. So try to figure out C, use a calculator. Do 9, -2 to find C prime. You want to use the whole decimal in a calculator. Okay, so if you take 7 and you divide by 3, and then you multiply by 9, you should get 21 perfectly using a calculator. That's why you need to use the round, like the whole decimal. Then I'm going to do 7 divided by 3, and I'm multiplying by -2. So I get -4.6 repeating. So these are my answers. So you're just multiplying by your scale factor. There's only, I think, 2 problems that your scale factor is ugly. Should we do one of them on the back? Let's do one more of the ugly ones. The ones that I'm going to leave you are very nice. Like number 3 has a scale factor of 3. Okay, so you don't have decimals. Okay, so I'm going to try to leave you the nice ones. Let's do another ugly one together. Let's do number 6. So number 6 says if triangle ABC has vertices A, B, and C, determine A double prime, B double prime, and C double prime after a dilation of a scale factor of 2/3. And then it's also rotated 180 degrees around the origin. So I have 2 things going on. This is like what we used to do whenever we would shift it and then we would rotate it. So first thing is I have my original coordinates. I need a dilation with a scale factor of 2/3. So in a calculator, if I take 2 and I divide by 3, because a fraction is fancy division, my scale factor is 0.6 repeating. So is it going to get smaller or is it going to get bigger? So if my scale factor is 0.6 repeating, should it get smaller, bigger? Smaller. So my numbers should end up smaller than they started because my scale factor is less than 1. So the catch is, because we're doing one of the ugly ones together, we're going to need to use the calculator, and you're going to need that whole decimal in your calculator every single time. So if A was -1, 2, I'm taking each value and I'm multiplying by this decimal. Okay, so I have -1 multiplied by 0.6 repeating. So if I take my decimal and I multiply by -1, it should end up negative 0.6 repeating. So we're going to just start by writing A prime. So negative 0.6 repeating. Now we're going to do the same thing for the Y. So I have 2/3, so 2 divided by 3, 0.6 repeating. And this time I'm multiplying by 2. So times 2 is 1.3 repeating. I'm going to do the same thing with B. B was -4, -3. I have to multiply by that ugly decimal. So I'm going to do 2/3, 2 divided by 3 is 0.6 repeating. I'm multiplying by 4, -4. So negative 2.6 repeating. I'm going to do the same thing with 3. 2 divided by 3 gives me 0.6 repeating. I'm multiplying by -3. So I get -2. Yes. Yes, go ahead. So try to find C prime using -6 and 1. Try to see if you can get use your calculator properly. So you should get -4. Should end up perfectly -4. And then 0.6 repeating. Perfect. Okay. So then the next thing we have to do is it says, then we rotate it 180 degrees about the origin. So this is the old stuff. If you look at the chart above, it has all the rotation rules in the chart. So for rotations, remember 180 degrees, it doesn't matter if it goes clockwise or counterclockwise. This is the rule that I'm using for 180 degrees. So I'm going to take my X and Y that I have, and all I'm doing is I'm making them negative. If they were negative, now they're positive. So the rule that I'm using for the 180 degree is I'm taking my X, I'm making it negative. I'm taking my Y, I'm making it negative. The only reason why it's positive if it's already negative. So A prime is now going to change to a double prime. So it was negative 0.6 and positive 1.3. So literally the signs are going to change. So if it was negative, now it's positive. And if it was positive, now it is negative. B prime, same thing. This was negative, so now it's positive. This was negative, now it's positive. So B is completely positive. So it's just changing the sign. And then C, the front number will be positive, the back number will be negative. So 4, negative 0.6 repeating. And because these ones, the numbers are a little ugly, let's just not graph it. That's just my answer. Most of the time on the EOC anyways, they're not going to have you graph it. They'll just ask for the coordinate point. Or it'll be like multiple choice coordinate point answers. How do we feel? Take a second, try number 8. You finish? Thank you. I emailed him. I'll just email him again saying that you're on your way back. Yes. Yes. Okay, so for number 8, all you're doing, it says if JKL has vertices, blah, 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 determine J, I don't know why it says double prime, but it should say single prime. Sorry, I made this. There's some errors. After a dilation of 3.5, because remember double prime means there's 2 transformations. This is a single transformation. So all you're doing is multiplying each of these by 3.5. It should be getting bigger because 3.5 is bigger than 1. So if J was 5.3 and I'm multiplying by 3.5, where should J prime end up at? Perfect. 17.5 and 10.5. For K prime, it is 5.1. So where would K prime end up? 17.5 and 3.5. And then the last one, L prime, it was 1.3. So where does it end up now? 3.5 and 10.5. So all you have to do is multiply by your scale factor. So I did 2 of the really ugly ones for you, just so that way you would have an example of the really ugly ones. Most of them are nice. You just have a dilation of a number that you're just multiplying by. What's up? Yes. Okay, so I want you to start working on the front first. If you want to use the graphs, you're more than welcome to use the graphs. If you don't want to use the graphs, you don't have to use the graphs. Either way is okay.